Hello everyone, and thank you for watching this video. My name is Bleynat and I'm a PhD student of the 36th cycle, and I'm working on the topic of Monte Carlo modeling and variance reduction technique applications for heavily shielded geometries. My advisors are Professor Zanino and Professor Rulla. The framework of this study is the decommissioning of the Enrico Fermi nuclear power plant in Trino. More in detail, the aim is to develop a computational tool that helps to evaluate the residual activation in supporting structure, especially the reactor pressure vessel. In order to do that, it's necessary to define different reactor cores because the reactor operated across 9 different operating cycles, and there have been some pretty serious modifications both in terms of geometry and in terms of enrichment. Therefore, analyzing one single cycle might not be enough. This is the calculation scheme that I developed. The first part is a criticality calculation, followed by a set of accelerated calculations for the transport of neutrons, and then some activation calculations, and then validations if measurements are available. The first two steps are repeated 4 times because we have 4 cores to analyze, basically. So the first step is just a criticality calculation that is required to calculate the source term. Therefore, a model has been developed inside Serpent2, which is the software that I used for this calculation. The second step is the acceleration of these neutrons towards the supporting structure. In this case, I was interested in analyzing the reactor pressure vessel. Therefore, all the neutrons were pushed to move towards this specific place, thanks to the application of variance reduction techniques. The steps 3 and 4 are the deterministic activation and result validation. This is more or less the specific activity that we're expecting in the reactor pressure vessel internal liner, which is made of stainless steel and is very prone to activation due to the presence of nickel. The reactor itself doesn't seem to be very activated, both because it operated for a very short time compared to other PWRs, and a lot of time has passed since it was shut down. The results were validated using some measurements that were performed on a sample of the liner and on some dosimeters, and the calculation scheme performs quite well. A second hypothesis has been tested in order to see if selecting a single operating cycle would be enough to describe what happened to the reactor during this life. And so this representative operating cycle hypothesis has been tested using an average core. And in fact, it seems to work very well. It predicts the residual activation very well. It's just slightly overestimated. So in conclusion, this hypothesis performed very well, despite not being usually used for this kind of reactors that had a lot of different modifications during life. But its implementation is quite easy, and therefore we're very happy with that. So thank you for your attention.